Okay, so we're back with another exam walkthrough. This is going to be question 13 from 2020 Jan Unit 1. So it says a book of length L and weight W is positioned on a shelf as shown. That's shown as the center of gravity, and it's a physics book. Okay, and we have length L, which is the length of the book. I want you to keep this in mind. We'll come back to it later. Length L is the length of the book. And then obviously quite a repetitive question, state what is meant by center of gravity. So that's going to be the point at which weight appears to act. This word is key, and that will get you 1 mark. Now, let's move on to the next question. Part B. There are contact forces at the two positions where the book touches the shelf. The book is moved a distance x to the right as shown. The magnitude of the contact force R, which is this contact force, varies with x. Then they tell us sketch a graph below the variation of R with x between 0 and L by 2. We should mark the maximum value of R onto the axis. Okay, so what they want us to do is they want us to plot a graph. The R here is the value of that reaction force that we have here, the contact force. And then we have x, and it's in terms of the length of the book. The length of the book was L. So when they say L by 2, they mean that this x is equals to L by 2. So basically, half of the book is outside. So it's going to be something like this. So this here, this is going to be L by 2, and this is also equals to x, both things. And then when they say L by 4, we're just going to think that 25% of the book is outside. So it's going to be L by 4. Basically, 25% of the book is outside. And here, 50% of the book was outside. That's how we're going to understand it. And yes, hope that point is clear. Now to plot this graph, I've made it in a way that you understand it and you are able to answer it very clearly. So here I have arranged some things so we can understand this question properly. And I've made it in the form of 5 questions that I'm going to ask. The first one is, what are all the forces that we have here? So first we are going to look at the weight. So we have the weight. And if you read the question carefully, it's going to tell us that the weight acts directly from the center. If you look here, it's acting directly from the center, right in the middle. So that's one thing that you have to be very careful about. Okay, we can say that the physics book is uniform just by looking at this diagram they have given us, the center of gravity right at the center. So we have the weight acting at the center, and then we have 2 contact forces right over here. We don't care about this one. All we care about is this contact force. So we don't care about this force. It is there, but we don't care about it. Okay. Now, I hope that's clear. So right now, our x is 0 because none of the book is outside. So our x is 0. Remember, x is how much of the book is outside basically. Right now, none of the book is outside. So x is equals to 0. And what I'm going to do is I'm going to pick this as my pivot point. And when I pick that as my pivot point, all the forces that have their line of action passing through the pivot will have a moment of 0. This is a moments question, remember? So we completely get rid of the R2 and its moment. And we can see here that we have the weight, and the weight acts directly from the center, and there's a moment due to the weight, and there's a moment due to the contact force. And the moments are going to be equal to each other. This is going to be clockwise, this is going to be anti-clockwise. Anti-clockwise is equals to clockwise moment. And then we know the distance as well. This is going to be half L. And this is going to be L. I hope that's clear. You can actually tell this from the first diagram that they've given us. That's exactly what I've drawn here. So we're going to have half LW, which is the moment due to the weight. And then we have LR1, which is going to be the moment due to the contact force. The LL cancel out. So R is equals to half W. That's going to be the value. We're going to start from half W. I hope that's clear. I have actually put more questions, so we're going to answer those as well. Now, we're going to look at X, okay? What happens to X and what is X really? X is basically how much of the book is outside. And how is the X value going to increase? The X value will increase as the book goes more outside. So as it goes outside, X will increase. So you can see X increases. And then what is L? The length of the book. So we have answered the first three questions. I hope all of these things are clear. Now for this question, I have put an extra thing. Question number 4 is something extra. I want you to do this question yourself. This part, I want you to do it yourself and let me know the answer when we are in class. For part 5, I will do it, and just doing part 5 is enough to answer this full question, so I'm just going to do that. So part 5 says, find R in terms of W when X is half L. So when half of the book is outside. So when half of the book is out. So remember, when half of the book is out, right? And we still take this as a pivot. Remember, we still take this as a pivot. And we can see half of the book is outside. Okay. So we're going to say that this is going to be the pivot. This is going to be the weight. Remember, weight acts directly from the center. And this is going to be the reaction force. And we know that at this point, when this is halfway outside, when X is equals to L by 2, half of the book is outside and half of it is right over here on the shelf. And then we can see that the reaction and the weight are at the same place. So if we find their moments, we can see that R, and then we can see the distance from the pivot is L by 2 is equals to W L by 2. Okay, I hope that point is clear. And we can see that the L by 2 cancel out. So R becomes equals to W when we're halfway through. And then we can say that at this point, it's going to be W. And you can just draw a line like this. And that's going to be 3 marks right there. I think that's sufficient. Okay, now next part. Explain why the book will not remain on the shelf if X is greater than L by 2. Now, I've drawn some more stuff so you can understand it properly. So, before we go any further, remember the line of action concept. First, you're going to select a pivot. See if the line of action of the force passes through the pivot. And if it does, then there is no moment due to the force. If it doesn't, then there is a moment due to the force. So, what I'm trying to say is that let's take this point as the pivot. Okay, let's take this as the pivot. And what happens is that you can see that this is the line of action of the reaction force, and this is the line of action of the weight. When the line of action of weight passes through pivot, the moment due to weight will be 0. Now, when we move a distance greater than half L, if we take this as the pivot again, what we can say is that we can ignore the reaction force R because its line of action passes through the pivot, but the line of action of the weight does not pass through the shelf, and hence it's going to cause, the weight is going to cause a clockwise moment, and that is basically your answer. There are a few other ways to explain this, but I felt like this was the easiest to explain because once you learn this rule, it becomes really simple to understand it. So as the answer, the line of action of weight does not pass through the shelf, so there is a resultant, that's an important word, clockwise moment due to the weight. So 1 mark for this and 1 mark for this.